record for this, right? So this becomes 2x squared. Go ahead.
2x cubed.
Cubed?
Yeah, it was 2. Oh, no, that's where I messed up. Okay, yeah.
Minus 2k squared. Okay. So we used equating coefficients for this, I assume, right? So I see that this is a 2 here. Oh, well, look at that. This is a 2 here. That has to work out. So, by the way, squared clearly because of that, right?
Yeah,
So
I
then
just
we,
messed up the computations.
but do you understand from here what to do that?
Yeah, you can divide by x on both sides, right?
No, you don't use the phrase divide by x. Let's just quickly go over this. So, this coefficient must equal this coefficient here. This entire constant must equal this entire constant here. And therefore, these must also equal each other. Well, in yellow, it doesn't help us because 2 equals 2 is giving us no information at all, right? So we know the fact that negative 3k has to equal 9, but negative 2k squared has to equal negative 18. I mean, technically, we should be able to solve either of those and get the same answer. Did people try this and get the same answer? Yep, exactly. Because in one of the circumstances, if you solve this equation, you're going to get 2 answers. That's what Olivia's getting. Take a look at what's underlined in blue. If you set negative 2k squared equal to negative 18, you get k squared equals 9, and then k equals plus or minus 3. But not plus or minus 3 work, or both of those don't work for what's in red. So again, we set what's in blue equal to each other. We go ahead and divide by negative 2 on both sides. And as Olivia said, we get plus or minus 3. So it seems like k has 2 values. But if you just look at the middle term instead, in red, negative 3k is also equal to 9. So in this case, k is equal to negative 3. So according to our middle statement, k has to be negative 3. But according to our last statement, k could be plus or minus 3. So clearly our answer is just going to be negative 3. And because although both values of k work for the third constant, or the third part of the trinomial, for the second part of each side, we cannot use positive 3. It wouldn't work. We would get negative 9x here and positive 9x over here. And those are not the same thing. So the answer is what's in red. K equals negative 3. Equating coefficients. It's one of the easiest things you will do on the test tomorrow. It really is. You have to practice it. If you haven't practiced this, you might be like, what is going on right now? Because it's not something that's hard, but it's just new. Whatever these coefficients are have to be equal. That's why it's equating coefficients. These have to be equal, and then the constant is the harder part to recognize that this entire thing is a constant. Remember, anything that's not x in this case, x is our variable, anything that's not the x is the coefficient or the constant. Okay. So the answer has to be negative 3. We have 2 statements here. Again, this one says it can be plus or minus 3, but using the middle term, it says it can only be negative 3. Therefore, it can only be negative 3. It can't be both. And check the middle term. It wouldn't work. Try plugging in a positive 3 right here. You get negative 9x, and that's not equal to 9x on the right side. Just to write it at the top so we're clear, right? This is 3-7 all the way through 4-3. Okay, those are the topics on test 4. 3-7 through 4-3. Same process for all tests you could expect, Word problems at the end, part calculator, part not, the whole 9 yards. Next question for problem set. Jimmy, then Olivia.
4-1-25.
4-1-25. Do you have it in front of you, or should I get a book?
Yeah, I have it in front of me.
What do you got?
Okay, so it's kind of long.
That's fine. Speak the right way. Go ahead.
4t to the third minus at to the second minus 2bt plus 5, 10, that's the end, minus the quantity of ct to the third plus 2t to the second minus 6t plus 3, then that's the end, equals t to the third minus 2t plus j.
That's it?
D, yeah.
D.
Yeah, got it.
Okay. So this is just a long problem with equating coefficients, right? It involves subtracting polynomials, combining like terms on the left side, and then using equating coefficients. Does the question say find A, B, C, D, or?
Yeah.
So on the left side, I see I have t cubed. Sorry, let me get rid of that. It's in my way. I have 4t cubed minus ct cubed. Watch what I'm going to do, please. If you haven't picked up on by now how to do these problems, let me show you a quick way. So we think about these as like terms. If c were a number, such as 2, hypothetically, if c were a number such as 2, how would you combine those like terms? What would you physically be doing? Again, if it's 4t cubed minus 2t cubed, what would you just do? It's a simple question. What would you do? Subtract the coefficients, right? So what should you do?
Subtract the coefficient.
But it's not a number. So Nick, how do I write that? How do I write 4 minus c?
4t squared t cubed minus ct cubed.
And what can I technically do then? If t cubed is in both?
You could do t cubed and then parentheses 4 minus 3.
Yeah, and that's the way I should write it. Let's jump straight to that line. We don't need the middle step there. That's right. You're absolutely right. This is correct. But this is what I want you to start figuring out. You should be able to pick up on this by now. If you have 2t plus 5t, it's added up to 7t because you're adding the coefficients, right? So here, you would simply subtract the coefficients. So that's what I'm doing, and I'm putting that in front as a group. And then I do the same thing for all the other terms as well. So the next part I'll do in blue. I've got negative at squared plus 2t squared. What does that look like when I write it this way? The same way, Sean. What should I write it as?
Negative, the product of negative 2 minus a times t squared.
The product of negative 2 minus a. I'm going to put negative a minus 2 just to be consistent, and then t squared. That works. You see what I mean by that, Sean? Just because we're going left to right. So this is becoming, take a look again. This is negative a t squared minus 2t squared. So if I want to write it as Nick Petralia told us a minute ago, you could think of this as negative a t squared minus 2t squared. And then when you factor out the t squared, you're left with negative a minus 2, and that's what's in here in the parentheses. I could then do the same exact thing for the next part. I group these two together. And again, if b were a number, I would take that number, multiply it by negative 2 here, right? And then I would go ahead and subtract the negative 6. But it's not a number, it's a variable. So this next part becomes minus 2bt minus negative 6t, so it's positive 6t. And then what I do is I have to recognize that when I factor out a t out of these, I'm left with negative 2b plus 6. And notice what I'm doing, by the way. First of all, this is a b, and this is a 6. They look very similar, right? That's a b, and that's a 6. Notice that I'm not even changing the order of anything at all here, right? I'm not even changing the order. I'm going ahead and literally just extracting the coefficient of negative 2b, and that goes here. I take the coefficient, which in this case looks like negative 6, but it's not because it's minus negative, so it's a positive 6. And then finally my constants. I have a 5 minus a 3, which simply gives me 2. All right, 5 minus 3 gives me a 2. And that whole thing equals t cubed minus 2t plus d. So if on the test tomorrow you are comfortable, this is where we get finished with our test. I talk about this all the time. There are 2 ways to do problems, or there are other ways, right? You can take the long route or the short route. I always encourage the shorter route. I would personally not write this middle line at all. All this that's here does not need to be written at all. You can jump right to this answer at the end here because you have a 4 as a coefficient, that goes here. And then minus c, that goes right here. Negative a, that goes right here. Minus 2, that goes right here. So there's no need for this middle line. Okay, there's no need for this middle line at all. I'd say we just jump right to the third line shown right here. Okay, I would jump right to that line. And at this point, now it's equating coefficients. The coefficient of t cubed on both sides has to be the same. So what's my first statement that I can write? Since t cubed has to have the same coefficient on both sides, what statement can I write to start?
T equals 4 minus t.
Careful. Not t equals 4 minus c. I can't do that.
T cubed equals.
What's the coefficient of t cubed? You guys both just forgot. Coefficient, equating coefficients. If it's not there, what's the coefficient? I'm asking Clark and Andrew right now. What's the coefficient right here? 1. You said t cubed, and you said,
T.
yeah, this is a 1 right here, right? And this over here is a 4 minus c. So read answer. Fix yourself.
C
Yeah.
equals 3.
Give me the statement. 4 minus c equals
1.
1. It's coefficients, right? So I take this coefficient here of 4 minus c again. I'll use yellow to show. I take the 4 minus c and I equate it to the coefficient over here. Well, there's a 1 in front of t cubed. You can't forget that there's a 1 there. Well, what's t squared's coefficient? Where's t squared? So what's the coefficient? What is it?
0.
0 in this case. Look, if it's physically missing, it means there's a 0 times t squared on the right side. So I start with 4 minus c, and that is equal to 1. I then next go to this, and take a look. I have negative a minus 2, but there's no t squared on the right side, so technically there's a plus 0t squared in this equation. So therefore, negative a minus 2 is equal to 0. Again, you're really missing t squared over here, so it's as if you have a 0t squared. The coefficient is 0 for t squared. The coefficient is negative a minus 2 for t squared. We set those two things equal to each other. We then move on to the linear term. The linear term is negative 2b plus 6, and that is equal to the other linear term, which is negative 2. And then last but not least, the constant. The 2 here is equal to whatever constant is there, so d is simply 2. That's the easiest one of them all. Again, the constant is 2, the constant is d, therefore 2 equals d. That one's done. The rest is simple math to solve, right? We can solve all of these as separate equations. We don't have to use a system at all here. No system is needed. Okay, so this c value becomes, when we go ahead and add the c over, subtract 1, we get c equals 3. The a value here, by adding a over, becomes negative 2. The b value, right, the b value, which is here, don't let this mislead you, that's a 6. Subtract 6, that makes that a negative 8. Negative 8 divided by negative 2 makes b equal to 4. So those are my 4 answers for this problem. But again, it is just like any other equating coefficients problem, except we have to recognize the fact that we have to combine like terms first. Okay, combine like terms first. That was Jimmy's question. Olivia was next. What do you got, Olivia?
It's not really just one problem, but like, can you go over like when to use what rule for exponents?
Sure. So we had 7 rules, did we start with, or 4 rules? 4. Okay. We'll do the other 3 later on in the year. That's why. There's 7 total that we go through. So the rules that we started with, first one was this. I'm going to use numbers. I'm just going to use numbers because a lot of people struggle on the quiz. Okay, this rule is add the exponents. That's what this rule is. The rationale behind that. Whenever you're confused about what rule to approach, just write it out. This is really x times x. This is really x times x times x times x times x. Notice, these are two things multiplying each other. There's no plus sign anywhere. There's no distribution. You're not double distributing. You're not foiling, anything like that. So I can just drop parentheses because everything is a multiplier. And there are 7 x's multiplying each other, hence giving me the answer x to the 7th. So the first rule is if the bases are the same, we add the exponents when multiplying the overall factors. John, what's up?
For the test, will we need to know the name for the...
No, definitely not. As long as you can apply the rules, you're fine. You don't need to know like power of a product or any of that kind of stuff. Those are just the titles because that's what they are. Okay? But you just need to be able to apply them. So that's the first one, right? We have another rule here. I don't know if I'm doing it in the right order, but I'm going to try my best. This one was a power to a power. And when that's the case, we multiply those powers. And if we're confused again, what do? We write it out. Think of this as x squared to the fifth. Well, that's just what this is. And then that becomes this inherently. Okay, think of x squared to the fifth means take x squared, multiply by itself 5 times. 2 plus 2 plus 2 plus 2 plus 2 gives me back to 10. So I can write it out and use rule 1. Or I can remember rule 2, which is just multiply those powers. Okay? Yeah, and that raises it to that power, though. So let's show that. So Olivia's question is, what if I have like a 2 over here? Well, that becomes a 32 then, because 2 to the fifth is 32. So this becomes 2 to the fifth like that, which is 32 x to the 10th. Olivia, the easy way to think about it is this. What's the power of 2? What power is right here, really? A 1. And 1 times 5 is just 5, right? So the rule is still the same. You're still raising a power to a power. So when you have a number by itself, think of it with an exponent as a 1. Okay, think of this exponent as a 1, and then it's 1 times 5, which makes it 2 to the fifth. 2 to the fifth is 32. What other rules were there? There were 2 others. 0 rule, which we should all know by now. Rule 3 is this. Anything to the 0 is 1. Do I have to go over that one? That's just memorization at this point, right? We need to know that. What was the 4th rule? I'm forgetting. What did I not cover? Which one?
I don't know if you know where this section, but if it's a negative power, it's a fraction.
Was negative yet? Did we cover that? Not yet. We will get to that, though.
It's
Is it a
power
quotient?
product, which is a b to the c equals a to the c.
It's this
b
one
to
here.
the c.
That's this one here. I'm not doing them in order. That's why I'm missing one.
Oh, okay.
Is it the quotient? Is there a quotient one?
Oh, it's a to the b times a to the c equals a to the b plus c.
That's the first one we went over up here. There were 4 rules you guys said. What's the 4th rule? This one, clearly. So, we got the same basis, adding the exponents. We got, in this case, where it's a power to a power, multiply those powers. We've got the 0 exponent rule. What was the 4th one?
Mixed product of powers.
Well,
Because
so
it was,
another question.
it was x to the second to the 5, and then we put a 2 in there, so it was just 2 in the second.
Oh, so both powers are encompassed in this rule right here, you're saying. Gotcha. So yeah, it's really, I mean, in the end, it's just 2 rules, right? Numbers 1 and 2. Number 3 should be memorized by now. Although I must make a statement that on the quiz, people really struggled. The quiz that you are getting back, did you get it back yet or no?
No.
You're going to get back in a minute? That last example, for me, was like a gift. I made them a half point each, thinking like, oh, this is an easy free point. But a lot of people really struggled. So for example, if I have a problem like this was one where people struggled. 3a to the 5th, c to the 4th, all to the 3rd times 2a to the 3rd, c all squared. How do I approach this? Somebody that is really comfortable, step me through the process. Clark, go ahead, step me through the process.
I would put the power to the power in each parentheses.
Okay, so what does the first one become?
So the first one would be 27.
Good.
A to the 15, c to the 12.
And the second one, Clark?
4, a to the 6, c to the 2nd.
All right. Then on the next line, I'm just going to rewrite the values down here with the numbers. Looks like another number there. Okay, what about at this point?
It would be 27 times 4.
What do we get from that? 108? 108, yeah?
1 a to the 21st power, c to the 14th.
Okay, very good, Clark. So again, remembering to evaluate the powers themselves first, or apply that power rule first, then go ahead and multiply through. And then go ahead. The other one that was the second part on the quiz, the other one was like this. All right, so how about a problem like this? And it just says simplify completely. Simplify completely is what the directions say. What's your rule? Remember, if you're forgetting or if you're confused because there's a lot of variables, think about your rule. What's your rule, Sean?
PEMDAS.
PEMDAS is a rule. It's not the rule here. What's the rule? We're multiplying things with the same base. So what do I do to the exponents? You add that. It's an addition rule, really, okay? So I think first, leave the x on the outside. Let's work out the inside. This becomes x to the n plus 1 plus n minus 3, all in the exponent. I'm adding the exponents because the bases are the same. Gus?
2n minus 2.
On the right side, this becomes x to the n minus 2 plus 2n, which becomes x to the 3n minus 2. Am I done at this point?
Right.
What's the one last thing I have to do still, Petralia?
Multiply the x and it becomes 2n minus 2.
Yeah, so what's the exponent for x, really?
1.
So,
So, yeah. Minus 2. Oh, it says, sorry, I thought it said minus 3.
gotcha, okay. Yeah, my 2's should all be consistent, right? I do sometimes this and then sometimes that.
Yeah.
My bad, yeah. Okay, so when I do this, I simplify here. This is a positive 1 and a negative 2. This will simplify to yield a negative 1. So my final result for this would be x to the 2n minus 1 plus 3 to the 2... Sorry, where did I get 3 from? Just carrying stuff down improperly. Really? And that's instead going to be... Why isn't this allowing me to rewrite? 3n minus 2. I can't... Well, why don't we erase it? So this does not change. This carries down the whole way. This is the one that we distribute a 1 to both. It changes the value of each. Yeah?
I have a question about another problem.
Yeah, go for it.
So on 3.9, number 12, or number, number,
3.9, number 20. Do you have it in front of you by any chance?
yeah. So
What do you got?
You have to like create the function, like equation, so it's f, and then like f of minus 1 equals 2,
Mm-hmm.
and then f of 2 equals 2.
And it says to write the function in linear form?
Yeah.
Okay. So, first, are we sure it's right?
Yeah.
Here's what I see. Let me discuss this, because this is one of those problems where the context might help.
It was in the C section, so it was like block.
Yeah, so I think here's what's happening here. This is the coordinate negative 1, 2, right? Have we seen that so far? And that's the coordinate 2, 2? Are we all clear on that? Let's pause for a quick moment and make sure we're all clear. All clear. If I tell you f of 0 equals 5, then the coordinate is 0, 5, like on the quiz, right? That was the y-intercept. What's up?
So would it be 2 negative 1?
No, so this is x. Whatever goes in here is x, and whatever comes out is y. Input, output. That's why they're called inputs and outputs. You plug x as an input into the function, and what comes out is the y value. The y value depends on what you plug in as x. Okay? Now, with these two coordinates, if it's a line, which it says it is a line, right? What's the only line that will work that goes through these two coordinates? There's no work needed at all. Jimmy?
F of x equals
Yeah, y equals 2. F of x equals 2. This is a horizontal line. Picture it. Picture these two coordinates. You gotta, yeah, picturing helps a lot too, right? Negative 1, 2 is here, and 2, 2 is here. The only way to connect those two dots is with a horizontal line passing through the y-axis at y equals 2. So this equation is simply y equals 2, or in the proper form, f of x is equal to 2. It's one of our constant functions. If you recall from section 3.3 that we did earlier on. Remember, x equals some number is what kind of a line? X equals some number. What kind of a line is that? It's a vertical line. And whenever it's y equals some number, right, y and f of x are the same thing. Whenever it's y equals a number or f of x equals a number, we know that it is a horizontal line. Is that clear? Okay.
Would you lose points if you put y equals 2?
If the problem asks you to set up the answer in f of x notation, you should follow the directions. So
We did it this time.
I wouldn't be too concerned about that. Sean, I would not concern myself with that right now. Gus? Yeah, go for it. What else we got? What else? Hey, there were some really good problems in 3.9 in this area of problems, and that's kind of where I got your quiz from. Remember I said f of 0 equals 5, and f of x goes up by 2 or 3 for every time x goes up by 7 or something like that. Those are good examples to be able to come up with functions for them. So let me give another one of those. So I told you that, the starting value of f of x is 3, and when x decreases by 4, f of x increases by 7. Starting value of f of x is 3, and when when x decreases by 4, f of x increases by 7. What do you got for me, Mark?
Well, what is starting value? Is that like...
Let me think. What is starting value for all these problems?
Oh, do you know like the B?
Yeah, the y-intercept, the b value.
So,
We assume all graphs start on the y-axis, even though it's not really, right? Because they go to the negative domain also. So again.
So f of x equals 7 over negative 4 plus 3.
Just like that?
X.
Okay. Yeah, there we go. Good. So, very good, Clark. So what Clark noticed is that when x decreases by 4, that's your delta x and your slope. It says that y, or f of x, increases by 7. So the change in y is 7. The change in x is negative 4. The starting value is 3. So as a result, we know that we have a slope here times by our independent variable plus the starting value itself. Let's try one that's a little bit different. Let's try this. Let's say f of 2 is equal to 7. And the slope is undefined. F of 2 equals 7, and the slope is undefined. Look at it. X equals 2. How come? How come you're able to answer that right away?
Undefined is a vertical line, which is an x equals something line, and we're only half values.
Very good. Remember, vertical lines are always given in the form x equals some number. And according to Olivia's statement, which makes sense, is, hey, you know what? If this point is 2, 7, here's the coordinate right there, right? There's a 2, and there's a 7. The only way for this to work is to have a vertical line going through x equals 2. Okay, the coordinate is 2, 7, and the slope is undefined, meaning it's a vertical line. How would the problem change if the slope were 0? What if the slope were 0, I'll tell you instead?
Horizontal to the y-axis of 7.
Yeah, it would be the line y equals 7. So a slope that's undefined becomes x equals 2, and a slope of 0 would be a horizontal line that would say y equals 7. So the second iteration of this is, what if the slope instead is 0, right? Same exact coordinate to start. The second part says, hey, what if the slope is 0? That's what happens there. Yeah?
So just to be clear, if it's a vertical line, what's the function?
Say again?
If it's a vertical line on 2, what's the function?
It's always x equals, remember, it's not a function, technically. It fails the vertical line test, right? This would fail the vertical line test because it intersects many times. But the equation of the graph is x equals 2. The relation, remember that word relation? That's technically the word for it, is x equals 2. Whereas the function over here is y equals 7. Okay? What else? What else? How we do on word problems?
Word problems are achieved.
They're very similar, right, in nature. You have some sort of rate of change that goes in for your slope. You have some coordinate or some value you can plug in to find the b value, or you're given the starting value. Or maybe you're giving 2 times, like the first problem on your quiz. That's a great example, right? The electrician with the work there. You're given 2 different coordinates, technically, by giving 2 different statements for the rate at which he charges or she charges for her electrical work. Right, $90 in 2 hours, and then $140 in 4 hours. So those are like 2 coordinates. You can find the slope, and then you can use them to find the equation. How about those problems like the one that we did that was a little bit trickier? Like, you don't have to pay for the first 20 minutes, but after that you have to pay. Remember that thing? Remember that question? Here, I'll give you an example. Let's say, if I can come up with it in my head, yeah, I can make one that works. Let's say we have, okay, every month, this is a perfect example. Every month, your data charge for your phone, I'm just dictating, so if you want to write, you can. Every month, the data charge for your phone is always a flat rate of $20. The data charge for your phone is always a flat rate of $20 for the first 5 gigabytes used. Again, the data charge for your phone is a flat rate of $20 for the first 5 gigabytes of data used. Write if every gigabyte beyond that costs $8.50, if every gigabyte used beyond your 5 gigabyte limit costs $8.50, then write the function that represents this model for values greater than 5 gigabytes per month. So there's a couple steps to this process, and I want you to think about it first. I want you to think about the fact that the first 5 gigabytes are already covered and paid for every time. You drop the $20 every month no matter what you use. Even if you don't use the first 5 gigabytes, you're still paying $20 a month per gigabytes. It's only afterward that you pay more, right? Only afterward that you pay more. So I know already that I've got to have a plus 20 on the end. Everybody agree with that statement? I think that's the easiest thing to notice right away. You have to pay 20 a month. It's after that it gets a little confusing because most students would probably answer with 8.5x in the front there. And they say, oh, 850 times every gigabyte over is what's going to cost you there. But the problem obviously is that x is the amount of gigabytes used, not how far over you went. X is the amount of gigabytes used, not how far over. So what do I have to do in a problem like this? Olivia?
8.5 times the value of x minus 5.
Yeah, we have to account for the 5 gigabytes that have already been used. So if x is the number of gigabytes used per month, the overage is that number minus 5. If you use 9 gigs this month, how much did you go over by? You went over by 4 gigs, right? And where's that coming from? 9 minus the 5 that you already paid for. Now, here's the question for you. Ready? What is the domain of this function? When is this function applicable? What is the domain for this function, Jimmy?
All numbers greater
Very good, Jimmy. It's got to be greater than or equal to 5 to use this function, because what if x is 4? What if you only use 4 gigabytes? How much did you pay still? 20, right? But according to this model, it's not true, right? If I plug a 4 in here, it takes off money. It takes $8.50 off of 20, which is not reasonable. Because what if I only use 1 gigabyte? Think about it. You would get money back, wouldn't you? If you plug a 1 in here, negative 4 times 8.5 is like negative 34. Negative 34 plus 20 means you would get $14 back from the company for only using 1 gig, which isn't the case, obviously, right? So this has a restricted domain. So what does the function become for the domain of x is between 0 and 5? For the domain when x is between 0 and 5, what is the function? It's much simpler. Sean?
Undefined.
No, not undefined. There actually is a function for this. For x less than 5, or between 0 and 5, what's the function?
20.
It's just 20. Think about it for a second. Hey, think about it for a second, please. Make sense of it. Everything that you do up to 5 gigs is still going to cost you $20. That's the flat rate. You know that if you only use 1 gigabyte, you're still paying $20 a month for the 5 that you paid for ahead of time. It's like a prepaid plan, but if you don't use it, you lose it, right? Have you ever bought something before? For example, how many people play Xbox Live? You pay per month or per prescription or per subscription, but if you don't use the amount of hours that you can, which is unlimited, right? It's 24 hours technically, you don't get money back. You're still paying a monthly rate. So in this case, you're always paying at least $20. So if you don't use up to 5 gigs, or if you use less than 5 gigs, you're still paying $20 a month, no matter what. So this is the domain from 0 to 5, that's from 5 beyond. Hey, after school today I have office hours, so if you want to come by and ask more questions and visual stuff, or do more word problems together, I'll be here in this room, so I recommend you come by. So to everybody, and won't be juniors, and just freshmen today, so you should all come in that room.
The juniors go to retreat, right?
They're on retreat, yeah. And their test is on Friday because they have retreat today and tomorrow. Your test is tomorrow. Yeah, it's retreat, and then a half day kind of, right? For the C day? It's true, I guess.